Okay. Welcome everyone to Ethereum Development with Web3j and Java, a hands-on workshop brought to you by Web3 Labs and the Hyperledger Foundation. We'd like to thank everybody for joining us today. We're very excited for this workshop. One thing to note, this meeting, as with all Linux Foundation meetings, is held under the Linux Foundation antitrust policy. A link to the Linux Foundation antitrust policy is included in the links I'll be sharing in chat, as well as the Linux Foundation Code of Conduct. Through the course of the workshop, feel free to ask questions in chat. Unfortunately, in a format like this, it's incredibly difficult to do voice questions, so we're going to keep all the questions in chat. It also gives us the ability to capture the questions. I'm now going to turn it over to our three fantastic presenters, Connor, George, and Nishal. And I'd like to thank everybody for joining us and take it away.
Well, thanks so much, Sean. I'll just turn on my video so at least you can see me in the corner there while I'm speaking. So, hi everyone, I'm Connor Svensson, joined by George and Nishal as well. And George and Nishal certainly will be your guides for much of the workshop. I'm here just to give some historical context as I originally wrote the Web3j library many years ago. If we just go on to the first slide, please. Okay, so here's the overall agenda for the session today. So as I said, I'm going to just kick things off with a bit of background context, and then the Nishal and George, the maintainers, will be talking about really the roadmap, getting involved in the project, the architectural overview, and they'll be doing the demo and the workshop and fielding your many questions as well there. We go on to the next slide. So to give you some context on me, I guess my original background was in institutional financial technology. So I was really working on these large applications for various different banks over the years, covering lots of different asset classes and supporting different types of businesses in those banks. But I think the best way to think about it is well, some parts of it were writing very high performant code. Some of it was more about implementing complex business logic in code and with less of a focus on performance. But I think the point was it was quite a good amount of experience building these large sort of systems to serve institutions. However, back in 2016, I got interested in blockchain. In my research, really found Ethereum. Ethereum reminded me of Linux back in the sort of late 90s and early 2000s, and there was this technology with this amazing community around it. And as a result of it, I wanted to find ways to contribute to the ecosystem. I'd spent all of these years working in large corporates who were building on the JVM, going back to the early 2000s. In the sort of subsequent 20 years, they built large parts of their platform infrastructures on this platform. And with all of the discussions about this transformative potential of blockchain technology, I thought there was a fairly obvious problem that needed to be solved here. And this was to enable all of these organizations to work with what I believe to be the most relevant and important blockchain technology, Ethereum. So I wrote the Web3j library back in 2016. That was when I sort of put out the first release, and then 1 year later founded Web3 Labs. And in the years that followed, I'll talk a little bit more about what Web3 Labs does in a minute, but I was very involved as well with standards creation. I was the chair of the technical specification working group at the Enterprise Ethereum Alliance, which was a role I did for 3 years, where we produced the world's first enterprise Ethereum client spec. I also wrote a book, the Blockchain Innovators Handbook, which is really a guide for organizations wishing to implement blockchain technology there. And also there's a podcast as well, the Web3 Innovators podcast. We go on to the next slide. I believe the guys are going to do a quick intro about themselves as well. So George, over to you.
Yeah, thank you. Thank you, Connor. Hi, I'm George. I'm a senior software engineer. I started my career more than 70 years ago, mainly worked with Java in different kinds of industries, such as fintech, pharma, and life science, and also automotive. For the past 2 years, I've been here with Web3 Labs, helping enterprise customers getting the most out of interacting with the Web3 space. And also, I'm the maintainer of Web3j and an active contributor of Hyperledger Besu project. Nisha, if you'd like to step in.
Yeah, hey, thanks, George. So, hi everyone. So, I am a backend developer and been, developing an Ethereum ecosystem from past 3 years. And also, I am working with George as a maintainer on Web3j and been with Web3 Labs from past 1 year. And yeah, nice to meet you all. Thank you.
Okay, so to give you a little bit of context about what Web3 Labs do, we're a decentralized infrastructure solutions provider. We're based out of the UK, but we have staff in a number of different countries, such as George and Nishal here. But really, there's three things that we do. One of them, which we'll obviously be talking a lot about today, is the Web3j integration library, continuing to maintain and support it because we believe it's a very important piece of infrastructure for the entire Ethereum and enterprise ecosystem. Without it, as I'm sure you'll see, there's an awful lot of code that would need to be written every time someone wanted to talk to Ethereum. So we believe it's a sort of fundamental public good that really is needed to serve the community there. We also provide support for Hyperledger Besu. So George and Nishal also work on the Hyperledger Besu project. And there's a nice reciprocal relationship between the two projects in that Web3j uses parts of Hyperledger Besu inside, and Hyperledger Besu uses parts of Web3j as well. So both are on the JVM platform, and there's some nice sort of crossover there as well. We also have our Chainlens blockchain explorer. So Chainlens, we've got a little screenshot of it there, but it's a very fast, modern, and efficient block explorer. So I'm sure many people are familiar with that, but what they are. So when you run up a blockchain network or app chain or layer 2 or layer 3, whichever sort of flavor, an explorer is a key piece of infrastructure for network operators to see the activity that's happening on the network, but also for users to actually have proof of activities taking place when they undertake a transaction. So that's something else that if you want to learn more about, you can learn about on our website or chainlens.com. Customers, we're fortunate to have worked with a number of different, both, I guess, native Web3 companies, as well as traditional enterprises as well. So spanning Microsoft, JP Morgan, and Vodafone, some of the more traditionally well-known names, but also R3 Consensus, and had a number of grants from the Ethereum Foundation as well for Web3j. Just move on to the next slide. Okay, so I'm just going to give a quick overview of Web3j, and just to check, George, you'll be jumping in after this, yeah? Cool. So in terms of Web3j, it's, as I said, the Java integration library for Ethereum. But what does that actually mean? When you have a Java application, if you want to talk to the Ethereum network in any way, when I say talk to, it can mean read data from the Ethereum network, such as what's happening with these blocks that are being created on the blockchain or the transactions within them, or it could be sending Ether, the cryptocurrency, from one address to another, or some other token. It could be deploying a smart contract, or it could be transacting with an existing smart contract. All of these sorts of activities, if you're on the Java platform, can be done using Web3j. It's basically that, and you can see it in the picture here, you have this sort of integration layer where it talks this JSON RPC protocol, which is the standard way in which we communicate with Ethereum network nodes. But what Web3j does is that it takes care of all of the heavy lifting there as well. So it enables Java developers to work with Java types, even though the underlying platform that they're dealing with is the Ethereum virtual machine, which has its own virtual machine in the same way that Java has its own virtual machine. So it takes care of all of that type mapping behind the scenes, but also does things like the cryptographic key creation and signing, the encoding and decoding of data. Ethereum uses a number of different types of encoding and decoding services. You have what's called RLP decoding, which is like a wire protocol decoding that gets used in transactions. You have API decoding, encoding, which is used for smart contracts and all this sort of stuff that happens behind the scenes. Web3j takes care of it all. So Java developers can keep working with Java and do everything they need from within their Java development environment, with the one caveat that the smart contracts themselves are written in Solidity, but when it comes to deploying and talking to those, people can work within the well-known Java there. So that's kind of, I guess, a very high-level overview of what Web3j is. And I'm going to pass over to George and Nishal now, and they're really going to take over from here and really get into the details and get everyone's hands dirty as well during this workshop. So over to you guys.
Great. Thank you, Connor. Thank you so much for the great intro. And now just to go further, I will add only some few points over the intro related to Web3j that Connor just mentioned. And why exactly do we need this Web3j, this Java library that allow us to communicate with Ethereum? And one of the main reasons is that we know that there are big enterprise systems that are running since more than 20 years on Java on the JVM, and it's really hard to figure another way in order to change the infrastructure or the software that are already used in there. And for that, Web3j comes just in hand and really helps with wiring the existing enterprise JVM system with the Ethereum network. And also, when we are thinking to enterprise, we are thinking that, okay, maybe we need in there a library that was heavily tested and we know exactly what it can offer, and there is already a community. Preferably, we would like to go with something that is open source and updated day by day. And we can assure that for the past 7 years, Web3j has been intensively tested by the Ethereum community. And we can say that it got its approval even more, that now it's part of the Hyperledger Foundation. Also, Web3j, in terms of functionalities inside, it offers a really nice typeset mapping from the EVM types to the JVM, and like this allow to an easier map and interaction with the Ethereum ecosystem. And also related to the next point, it has some really nice testing capabilities that are used in even if the development of Besu Hyperledger system. And that testing capability is that it offers an embedded EVM node in order to run unit tests or integration tests. And also this great functionality we'll see later in this workshop. Also, the architecture, it's modular and you can use only what you need, and we'll go in details in the next slides. And the last thing is that it offers great privacy transaction support for the private networks, especially when one example in here we can mention, as example here we can mention Besu Hyperledger. So going next, as a roadmap, obviously, even if it has 7 years almost since it's intensively used, we are still trying to make it better day by day and add some new functionalities that are asked by the community. And as a roadmap for this year, we would like to have a version of the Web3j Android updated, because the one that the existing one was updated now 2 years ago, and some functionality are missing. And also a really nice thing that we like to have is to update and enhance the IntelliJ Web3j Solidity debugger. For those of you that are not aware of it, there is a debugger implemented, which is using Web3j and can be added as a plugin to IntelliJ, and allows you to see the stack trace and everything that a transaction could offer. As an example, you could see it in the Remix debugger. Also, one thing that is missing in Web3j and we'd like to add is the generic struct functionality. And also there we are collaborating with some contributors and we're trying to add this as app. And of course, after we'll add all of these, we are aiming to release a new major version of Web3j. And initially, we would like to give some details about getting involved.
Yeah, thank you, George. So everyone, like whoever, who has never did coding, wants to get started, or who is already in the Ethereum field and wants to contribute, they all are welcome to, get involved with the Web3j and file bugs or solve bugs and raise PR, even if it's a small PR. First thing is, if you find a bug, so ensure the bug was not already reported by searching in the GitHub under the issue page. If it is already reported, then you can give it a +1 and add some additional comments and information, whatever you have. So we will look into that. And then if if you are unable to find the bug, you can open a new bug and ensure like all the title and description is clear, and you can provide as much information about that, and even the code sample and how to reproduce the error. You can just give it about that, so we can reproduce in a local machine, and we can fix that as soon as possible. And if you have written a patch or a fix for the bug, so make sure to open a PR, a fork our Web3j repo, then raise a PR and describe what the solution you are providing and which bugs you are solving, which issues you are solving, and make sure the your PR you have like executed this spotless apply, so the build won't fail. And you can add me and George for getting in reviewed. So once we review the PR, we can merge it. And if you are want to add a new feature or want to change existing one, you can directly contact us on Discord, or even like mail us, and we will look into it. And if you have any other questions or discussion, you can surely like contact us over Discord. So this is the Discord link. There's a QR code. You can scan it. And if you are not able to find the Web3j channel, then join the Hyperledger server. Once you join the Hyperledger server, you can like contact us over the Web3j channel. And the other thing is GitHub link, which you can scan it and you can look into our code. Oh yeah. The next slide. Okay, so recently we have the Hyperledger Web3j wiki page. So you can go over that and the community space. You can join the mailing list. You can get all the information, new information and announcement, new Web3j releases over there. And you can also, we will be having our first community call on 3rd April. So you all are welcome to join there to listen and to contribute whatever you have in the community call. And we are going to have it every 2 weeks, after like every 2 weeks, like twice in a month. So you all are welcome, and you can like scan this QR code and get an invite for that. Over to you, George.
Great, thank you, Nishan. And also just to finish with the introduction, here are our details related to Web3 Labs, also another place where we can find me, Nishan, and Connor, in order to help you with Web3j or with any related blockchain stuffs. Okay, so with this slide, we are officially starting our workshop from today, and we have some, as some of you may see in the description, we have several topics that we'd like to cover with practical exams, and also like with the theory. We'll start with the Web3j architecture. As I was mentioning in the previous slides, it has a modular architecture, and by this, what is really cool about this is that you can import it in your project or add it as a dependency, only what you need. And for example, here are added the modules available in the Web3j, and here is a short description of every of it. And we can take the crypto module, and we can see that okay, it offers support for the wallets, for the key management. Also, lately I added a new functionality, which is the JSON key file format that can be used also in generating, for example, decentralized identities. And also as other modules, we have the code generation, we have the console. Here, the code generation is used in generating the contract wrappers. We also have the tuples, we have the utils modules, and the utils is used, what it really offers are the hashing functions that are used in order to generate the right data, hex data that can be sent further to the Ethereum network. And also I should have a project open here. 1 second, because I would like to navigate with you a bit throughout the project. Okay, cool. So I changed my screen. I changed the presentation screen. I hope that now the IntelliJ is visible.
Yeah, it's visible.
Okay, great. So as we were mentioning before, we are looking for some new contributors, and just to give you like a spoiler, this is the Web3j project, the way it looks like. Here are the projects split out in modules, and as I was mentioning in the beginning, we have the crypto, and here in the crypto we have the specific classes, and for example, also in crypto, we have the cryptography classes, but also we have, with cryptography automatically comes the signing, and here we can see the signing class. And also we have this module that is support interactions with GET, and also in here we have, in order to support this interaction, we have also some RPC method. And also related to the RPCs, we support the full, we provide support to the entire API RPC, which is available now and used by the EVM clients. Okay, and obviously you can find more like during your contributions or tests or whatever. And we're looking forward to find your feedback, and as was Nisha mentioning, your contributions on the GitHub repository. Okay, so now going back to the presentation. The next thing that is also that cannot be also involved into architecture and is part of the Web3j are these two projects, which are Web3j unit and Web3j EVM. And the Web3j unit, what is mainly, it's a G-Unit extension that is used by the Web3j in order to execute its tests. And by this extension, what I want to say is, just to give an example, just let me open the repo. To show you a practical example of the unit. Second. Okay, great. I found it. I'm going to share it right now. So, and also just as parentheses, we have example projects for most of the projects that are used by the Web3j in order to be easier to understand. Okay, so in here we have an example of the unit, and by this what I wanted to say is that this Web3j unit acts as an extension of the G unit. And by this is that it mainly provides this annotation, which is a EVM test. And by this, when you are specifying in here, we can see in here the test annotation specific from the G unit. What it will do, it will create in behind a node, a EVM node. And depending by the type, that node will be Besu node, embedded node, or get node. And when this takes place and runs, all these arguments in here are coming by default. And then you can execute, when having all these three here, you can execute the contract the way you want in order to test it. But also for this, we'll have a practical exam when we'll get to the ERC-20 token. practical use. Okay, and as I was mentioning on the Web3j unit, this one can run the EVM nodes like Besu or Get nodes. Those can be run in a container, or also we have the possibility to run it as a Java process. And by this, we have created the Web3j EVM project that gives this support. But I think it will be, just to go back, I think it will be more understanding and more easier to understand when we'll get to do the practice. Okay, and now we'll switch to the hands-on demo. And for the beginning, we'll start with the ERC-20 contract, smart contract that we'll try to execute. Okay, so I will take out this Web3j. So also another thing that I wanted to say, we'll do the demo step by step in order for you also to be easier to do it in the same time with me, or if you come later and check the recording on YouTube to be able to do it as a tutorial. Okay, so first, let's generate the ERC-20 token smart contract, and for that we'll use the terminal. Okay, let me clean this. Okay, so first you need to have installed Web3j CLI on your computer. And to install it, we shown in, I don't know how many of you have been there in a presentation that we kept a few weeks ago. But I will do it again, although I have it already installed on my environment, but I will just show you the output and the command. So this is the command to install Web3j CLI. This one is also available in our documentation, things that were shared here in the chat. Okay, so it shows here that I have already the latest versions. And okay, next thing that I'm looking to do is to generate my new ERC-20 contract. So for that, I will need to run this command. This command will create by default a ERC-20 project, which will contain a wrapper of the ERC-20 smart contract and also the Solidity ERC-20 smart contract. But I would like also to customize this a bit. And for that, I will just mention a different package name. And for that, I will use con.workshop. And also, let's specify a name for it, and it will be sure. Okay. So now the CLI is taking care of creating this project, but in order to go further, I will need to specify the token name. And let's find the token name, and let's say to be Orton from Workshop and Token. Let's try that. Okay. And also a symbol, let's go with WTN. And also in here, we should specify a supply in order for this token, and we'll go with a lot of nines. Okay, so it seems that my project was successfully created, and now I'll open it in Web3j to show you how it looks like. Okay, so there we have the new generated ERC-20 project, which, as I was mentioning, it contains the ERC-20 token wrapper. Also in here we have the Solidity version of the smart contract, and in here we have a starter class that has in the main as a first action the deploy of the contract, but we'll update it a bit in order to make more sense. I mean to be easier to be understood and use. Okay, so we'll do some actions with it, and we are looking to deploy it on a network and also transfer some tokens to a new address and further allow that address to transfer further those tokens. So for that, what I will need first is a test network, and most of the time I prefer to use Besu, Hyperledger Besu network, and I'll just a second to start it right now. I have already run the quick start command, but what I can do is to run it again. Maybe some of you don't know about it, and when we'll execute again the tutorial, we'll get lost. So first I will need to remove this folder which was created. Okay, and now let me find the method that starts up the quick start Besu network. Oh. Okay, so this is the method that help you spin up, which help you create local folders with all the configurations that you need in order to run Besu. And in here you have some options that we need to select in order to go further. We can this one offers you also this support for the private transactions, and also some options for the block explorers, and one of those is chainless. Okay, cool. So it seems that the folder was created, and now in order to start it, we need to go in it and run the run script. Okay, it seems that I didn't start my Docker engine, so I'll do it right now. And in here we can see that I have already some test containers that I ran before. Just remove this. Okay, Docker is cleaned. So now we're running the network. Okay, cool. So it seems that the network started. This is the RPC endpoint, and also we have in here the Explorer and also other metrics that we can use for the network. But now let's get back to our ERC-20 contract. So what I will need in order to deploy my ERC-20 smart contract is the JSON RPC HTTP service endpoint, and also private key for an account that will be able to run and execute a deployment of the smart contract. So let me take this and add it here. Okay, so this is the node URL, and this one is used in here in order to create the Web3j. Actually, this Web3j is the entry point to communicate with Ethereum. And for that, as I will use this later, I will add it here. Also create it as a private static. Okay, and from here. I will clean this up a bit in order to make more sense. And in terms of credentials, as I was mentioning, I will use a credential object using and create that based on the private key. And for that, I will remove this as I won't use the wallet option. Okay, so. Okay, and 1 second to paste here also the private key. Okay, cool. So we have the Web3j. We have this one is the Web3j service that allows me to connect and also to interact with the network. Here we have the credential, and in here we have the deploy method, that will help us deploy the smart contract. Okay, so there is not, and just to talk about a bit the deploy method. Here it takes as arguments the Web3j service, the credentials. Also, like if you run transactions till now, you know that we need to place in there some gas limit and gas price in order to have our transaction executed. And further, it takes as an argument the name of the token, the symbol, and the initial supply. Okay, so now let's execute this. Also, this runs in debug mode, so we can see most of the actions that are happening in behind. And it seems that our transaction was executed. And in here, we can see the trace of the transaction. And 1 second, in here, as this ERC-20 gives the support to use this command in order to get the address to which the smart contract is deployed. And it seems that the address is this one. So we'll copy this and add it here. Okay, and we'll save it as the contract address. And also from now on, we'll send some test actions to this address in order to make sure that, okay, our contract is in there. And for that, we'll clean this main class. And actually, I will extract this to a new method. And let's call this deploy. And comment it out as our contract was already deployed. Cool.
Also, George, this question that this Java wrappers is built in or not in ERC in the Web3j library. So you can you show that also, like how we can generate the Java wrappers if it's not available, if it's
Oh, okay, sure. So anyway, like everything in here was saved, we'll run that. So we have the Solidity smart contract in here. And the way that this project was mainly generated is by using the Web3j grader plugin. And like, for example, if you create a project from scratch and you just add the Web3j grader plugin and would like also to add in it Solidity smart contract and generate using only this project a wrapper for it, what you can do is that you will need to add, as I was mentioning, the Web3j plugin. Mentioning here are some actions in order to here is a Web3j task that needs to be added in order to have the contract generator task available. And for that, you will need to add this and mention the package name of the new wrapper that you want to create, and also what exactly what smart contract would you like to include from this Solidity folder. And for example, if I'm going here and I will just remove this ERC20 wrapper, what we'll notice is that already I'm getting a compilation error because it's not able to find a class. And it's something that we expected. But I can regenerate that by going here to Gradle, Web3j, and generate contract wrappers. And if I'm going back here, I can see that this wrapper was generated again, and already the main class is able to find it and to solve the compilation error. Hope, Nishal, this will answer the question.
Yeah, thank you. Thank you, George.
Okay, great. So yeah, just okay, back to our interaction with the ERC20. Next thing that we are planning to do is to see, okay, if our contract is really in there and it has the mentioned supply. And for that, what I would like to do is a load function.
Sorry to interrupt again. So users are asking about how API and those bin files are generated.
How the API bin files? Okay. There is, as I was mentioning, there is this generate contract wrapper, and in here, mainly in behind it's Web3j takes care of everything. Like it takes the wrapper, it takes the text of the Solidity smart contract, and based on that text, mainly is doing a parsing. And based on that, as I was mentioning in the slides at the beginning, we have support for most of the types that, all the types that are in Solidity. And based on that, we are running some generation code, and that generation is just parsing the Solidity smart contract and creating the wrapper needed based on that. And we can go in here, like to show some more details. In here, the way that we choose to generate the wrapper is to create a class that has static fields and methods, and also all of them are public in order to be easier to interact to. And as you can see in here, most of them are returning where it was. Are returning some type references of addresses, or others are returning some other specific responses. Well, all these specific types are implemented in Web3j and acts as a wrapper for the Solidity types. And also these wrappers are and in terms of wrapper, I'm referring to the wrapper type, are further mapped to the Java types. And this is how the wrapper is generated. And also based on that, we are using in behind, there is another library, which is the Web3j socket. And that Web3j socket, it's using the Solidity compiler in order to generate the bin file and the ABI file. So mainly we are for those who are relying on the Solidity compiler. Hope this answers your question.
Yeah. Thanks, George.
Okay, great. Okay, now getting back here, just let's create this loading method. Load ERC20, create method, and what we'd like to do is the following. So this time we'll interact with the wrapper in order to load our contract, and for that there is already a method on it, which is load. And this one receives also almost the same credentials, except that we don't need this time to create to send the name, the symbol, and the supply, because the contract was smart contract was already deployed. The only thing that we need to send is this to add in here is the smart contract address. Okay. Hey, let me think about this. And most of you will notice that by interacting with the wrappers, it's not enough only to call the deploy method or, for example, any other function that we'll see later on. We also need to add the send method at the beginning, because this is really what triggers our method to be sent up, or our execution to be sent up to the EVMs. But in the case of the load, there is already a send on it, and that's why we don't call it this time too. Okay, so in here we have the ERC-20, and we are loading it from this address. And other thing that we are planning to do is we'd like to print the supply of this ERC-20 token smart contract. And for that, we'll just go with this approach. Let's see. Okay, and let's see what method we have to get the supply. Okay, there is in here the total supply, and I go with send. Okay, this will throw, it's possible to throw an exception. For example, if the Web3j that was set to the contract in here, the Web3j service, if it was wrongly configured or anything else, we could expect any exception. Okay. But just to be easier to read, I will write it like this. Should be a big integer. And here we have the supply. Okay, and now if we're executing this, okay, so the transaction executed, we successfully loaded the smart contract from the address to which was previously deployed. And we can see in here in the log that is the right supply on it. Yay. Okay, so going next, what else we can do is that, like, okay, we have this ERC-20 token that has already some supply on it. What we can do is to call a transfer function, because I mean this is what the supply should be for, like to transfer from one account to another. Okay, so I'll comment this out, and I will create the new transfer. Okay, so every time, like if you like just interacted with the smart contract and then obviously the application stopped, you'll need to reload it in or after you start up again your app. And for that, I will add it again here, and again try to reload the smart contract. Also, let's print the success message. Step one. Okay, and now what we can do, okay, if we're transferring this to an address, is that we can create an, we should add a new address here. Receiver. And let me find the address that should use in here. Okay, let's use this one. Also, we can do a check on it to make sure that it doesn't have any. And also, I mean, check to see what is the current balance and what will be the balance after we transfer the tokens. So for that, what we need to do is to, again, to print here a message in order to be able to see the balance. It would be balance transfer. That we, and in order to get the balance, ERC-20 has already a method on it, and we'll use that, and that will be ERC-20 dot should be something with balance of exactly this one. Balance of receiver. And also don't forget about the send. Okay, and now we'll do another log here with start transfer. And now we'll just do our transfer, and we'll call the transfer method that is already on the smart contract, and we'll put in here the receiver string and also the value. And let's go for a big, and the value has to be big decimal. I'm sorry, big integer. I used to say big decimal because, like, you know, when you work in fintech, you use that most of the time. And let's use big decimal value. Let's send to 20K, yes. Okay, and send. Okay, for most of the methods in here, even if we like might look that send or also most of the time, are they're returning different types, and in order to like figure out what type it's exactly returning in here, you can rely on the compiler and the suggestions, because we can mention it here like result. And as you can see, it automatically suggested the transaction receipt as a type. Okay. Cool. So now I'll print another log with the transfers finished. That's the transfer successful. Successfully executed, and now what we can do is that we can also print the transaction received. And also now we can check again the balance of the receiver. Balance after this time. Okay, and yeah, let's see what we get. Keeps executing. Okay, so the execution took place. Let's see if we got our logs. Let's look for first for the balance before. Okay, so it seems that for this address, the balance before it was 0, and after we can see that the transfer started. And let's see where it successfully executed. Okay, so it finished to be executed right here. And also this is the transaction receipt. And the receipt mainly is this, the result of the execution. And now if we are looking for the next log, we can see that, okay, the new balance of this receiver is 20K. So our transfer was successfully created. But taking consideration that we send it our token like from the address with which we deployed the smart token. Sorry, the smart token, the smart contract token. And now if it will be to transfer again the amount from the receiver, from this old receiver to a new receiver, we'll need to call the allow method on the smart contract in order to ask the smart contract, the owner, to allow us to send further the tokens. And for that, we'll just create a new method. And let's call this transfer from address 1. Actually, let's call it a transfer from receiver. Receiver 2. I don't know, maybe you'll find some better names. Okay, let's call this receiver 1. Okay, create this method. And pretty much the steps will be the same. Like again, we'll load the contract. And we'll call this ERC-20 token original. Actually, no, we'll keep this as it is. And now, as I was mentioning, we need to call that approve function in order, allow function in order to be able to send from this receiver money further to a new receiver. And for that, we need to create a new instance of this smart contract, actually to load it. And we'll say this ERC token, let's call it sender. Okay. So this will load from the same address, except that we will use the credentials of this receiver. And for that, we'll create some new credentials for this sender. And let me find the private key of this. Okay, so found it. And use this in here in the credential sender. Oh, great. And now what I would like to do is that first I will check the sender balance. And for that, I'll just copy this line here, add it here, balance before transfer, and it will be the balance of the sender. So then let me rename this sender. Sender credentials and call this. And also copy this address because this will be the new sender. Okay, again for the exception. Good. So what we are doing is that we are checking the balance of the sender. Then we are creating a new instantiation of this. Actually, we can move this here to make more sense. Okay, and so what we did so far is that we instantiated two tokens, one based on the original address, original credentials, and the second one is based on the credentials of the sender. And now what we are doing is that we are checking the balance before the transfer. And now what we need to do is that in order to be allowed to transfer, we need to ask for that, and we'll use the ERC-20 token sender in order to allow. Approve, and it will be the spender address, which is the sender one. And the value, let's say that it will be a big integer of, let's say that will allow to transfer only 500. Okay. And now if now I should be able to transfer from this sender to a new receiver. And I will add in here a new receiver. The address for it. Okay, and now we'll use the original ERC-20 token instance. Transfer from, and we'll use the sender, receiver, and the value will be a big integer of, let's say 400, because it's below the amount mentioned here. The integer value. Okay, and also let me print the balance sender balance, and here it will be receiver balance. Okay, these are two are before the transfer, and now what we'll do is after transfer.
George, there's a question like, why are we using two instances here, ERC-20?
Well, we are using two instances because I wanted to show the difference between the difference in which if you are using to try to approve from the original address, it won't work. And for that, we'll need to add a new ERC-20 token instance in order to be with the sender credentials in order to be able to run the approve. Because else, like if we were supposed to go from this from the original ERC-20 token instance and run the approve, or even go directly without the approve for the transfer from, it wouldn't have work, because this is also specific in the Solidity smart contract interactions. For example, I can comment this out and like avoid using sender approve and use only the use only the ERC-20 token original credentials and try to execute this. You'll see in a few moments that here it will fail. Here on the transfer from, it will fail. And also, like, we can comment this out. Okay, and we can keep it like this: balance before and balance after sender. And here receiver. And here sender. Okay, so we have the sender, we have the receiver. Okay, and then in here we have the transfer and also the approve. Let's run it first without the approve even. Just run the transfer from to transfer to. And I mean, this is the way that ERC-20 smart contract was designed to run. Okay, and let's also rename this because it's ugly. And transfer from sender to receiver. Or just keep it transfer from. It's pretty intuitive. Okay, and start running it. Okay, this is the sender balance. We can see that we run into an issue. And 1 second, I will go through it. Okay, so just first we investigate the logs. We can see that, okay, this is the sender balance before, and let's look also for the sender balance. And we don't have a sender balance after, unfortunately, because the execution failed here. And also let's look for the receiver balance. Also in here, the receiver, as it is new, it has also the value 0. Good, and now if we're going back, let's see, debug this a bit. Can see that we got an error here. You see on the transfer from. And the execution was reverted. I mean, the reason is execution reverted because it wasn't able to transfer this from this address to the other address. Okay, and now if we were thinking like, okay, then maybe I should approve this sender to send further. And for that, we'll run the approve on the sender. But here is the instance of the token, which is using the original credentials that were used to deploy the contract. And what I will do, I will just run again this method. Okay, so we can spot in here the sender balance. Also the receiver balance, and again it failed because on the same step it didn't succeed to do the transfer. But now, if you would like to go and approve this and send the approve request on the instance that has been loaded with the credentials of the of the sender, which is this one here. Hopefully this will run with success. So, okay, so we have the sender.
Like I just want to add, so basically, if you when you're loading an ERC20, you're creating an object. So if you see, there's a parameter credential. So whichever credential we are using for that account, we will be calling all the functions on the smart contract. So first, we are loading using the original account. So all the functions will be called on the original account. And the so we are creating one more because there's a different address, different account, right? And we want to call for that. That's why we are creating two objects.
Yeah, it seems that it fell for the same reason. Let's check again all the parameters that we have placed in here, because I could have easily lost one sender credential. So that just to make sure that it's the same with the sender. Also, like this, we'll find out how to debug it. Okay, so this should be the sender and the credentials. Okay, what we can check is to see the allowance that was given to this transfer from sender. Okay, here is the sender approve. We can check how much was allowed for this to spend. Okay, so it will be, let's go with this ERC20 dot allowance owner should be the credentials. And spender should be the sender. Okay, and adding a message to differentiate it. So, okay. Okay, let's run this again to see what is to be the output. See the yeah, it's still executing. check the allowance. Okay, this is a remote function call that which is returned. Okay, as I was mentioning, I've got the sending here. Okay, I found out what I was missing. In here in the approve, it's not the sender address because the request is made out from the sender. I should have paid attention to your comments initial earlier. And in here, the approve should be actually the owner, because we are sending from, the sender is sending an approval request to the owner, and that's why it's sending from the contract instance that was created with his credentials. And 1 second, I will just update this in here. Oh, okay. Okay, let's see if last time the allowance was printed. Yeah, the allowance was given. But it wasn't, the request wasn't made properly. Okay, so it seems that our transfer executed, and we can see that the receiver received the balance of 400. And also, if we're going further, we see the other balance of the sender, that right after the transfer, the sender balance was 19,600. So, yep, seems that our approved request was accepted and the money successfully transfers from one account to another. And just to run another test, I will just comment out this approve and also the sender. And I will try again to load, not this one, this. And I will try again to send the same value from the sender to the receiver. Again, 400. Keep in mind that the last time we just approved only 500, from which 400 were already spent. So typically, we expect now, as we are running this again, this to fail, because 400 is bigger than 100 that left in there. So execute this again. Let's check the balances in the meantime. Sender balance before transfer. The same as before, as I seen. Okay, it failed accordingly to our presume. And also, if you are going to check the received balance, it was 500, for those 400 that were earlier transferred. And now, if we're going to the stack trace of the exception, we can see that again it was the execution, it was reverted as we went over the limit. Yep, so this is what I was mainly looking to show you related in interacting with the ERC-20 token. Hope it makes sense. Nishol, are there any questions related to what we demo so far?
No, so it was basically around this approving, and I think you have already explained that. And then
Okay, thank you.
we had I think some questions related to like one one user is not able to download basically install the Web3 CLI. So I have given that instructions, and
Okay.
yeah, I think that's it. And whatever we are have in the chats, I'm replying to them.
Okay, cool. And hope everyone is still there. I didn't. That wasn't boring till now, and I don't lose your attention, folks,
Going great,
because we're
George.
still. Thank you. Because we still have a lot to show you. Okay, great. So this was the demo related to ERC-20 token, but and now what I would like to show you, it also how you will be able to test these smart contracts like using a unit test or integration test. And I don't know if you remember from the slides that I presented earlier, there is the Web3j unit, and that Web3j unit, it mainly it is extensions of the G unit. And just to show you how you can easily interact with it and test it, I will just show you this test wrapper that was generated. And what we have in here are just the methods that were generated by default. But if you would like to run this, like you will notice that most of them will fail because these were added only as a draft, as a sketch, in order for you to be able to generate and to write and to help you write the methods, the test methods that you need. So I'll comment out most of the methods that will fail. Okay. And now let me just show you how to rewrite this in order for you to be easier to interact with. So what I will do is that I will add this before all ahead of most of the instances, and I will just run through only a few tests, and this will be the name check, and also let's check the symbol. Cool. So you can see here that this was generated, and okay, and in here we have like what it looks like, what it looks to a unit test. So starting from the top, we have in here this annotation. This extends the GUnit annotation. And mainly what it says is that, okay, when you start this test, you will be starting in behind the GVM process that will run an EVM node. Also, this can be customized, and like we can mention in here some other types. And those could be, for example, Besu, a node type Besu, or also get. And also this can be customized and using the compose and use a Docker compose file with your own configurations that you'd like to use in order to run your tests. But for now, I will keep only the EVM test. Okay, and let's see what else we should update in here. Good. So as most of you already know, here is the before all method, and this is executing the deploy. And we can see in here that again is deploying the ERC-20 smart contract with the data needed, the token name, the symbol, and the amount. And in order to like, I mean, here we can keep it like this, where you can update it by your needs. And if we are keeping it like this with the replace me fields, let's see what it will return. So we have only 2 methods left in here, which are not commented out. So yeah, let's get it started. Okay, so obviously this one passed. Like we have the assertion which are trying to assert this replace me with the data that we are retrieving from the smart contract. But what if we are going here and change this to the token name that we just created to the Corton? Let's write it with lowercase. Corton N. Corton, and run this again. Obviously, like these two are failing because, okay, it says that we are expecting to replace me and instead we are getting a Wharton. So let me update also this here. So now if we're running, this will deploy again the smart contract. And yep, this time will pass because it's getting the expected values. And also what I would like to run is to change this to a Besu type to see, just by curiosity, what results we'll get back. Okay, and if you remember, we are already running a Besu environment, which are using the well-known ports or the well-known RPC ports. So like we should expect to have an error when we'll spin up this again if it will run properly, because this will also try to start in the backend a Docker environment based on Besu. So let's run this. So yeah, as I was mentioning, most probably we have an initialization error, and that error should be because it's not able to allocate the port because it's already exactly the endpoint, because the port is already allocated. So now what we need to do is to go back here and stop our environment. Let's see what scripts we have in here. Start, remove. Let's go with
It's remove.
remove, exactly, to clean everything. Cool. So just to look again at it, everything's clear. So now if we will run this, we expect here a Besu node to start with the expecting port 80. Okay, and as it executed quickly, we might see that what I wanted to say is that as it executed quickly, also the JVM took care of our container and closed it. And like this, you can write whatever unit test you may need in order to make sure that your functionality is in there. We can go in depth in here, but then we won't have time to cover the other aspects. Also, you can find, as example, this type of tests, we can find them in the Web3j repository, but also for those of you which are familiar with Hyperledger Besu, you can find them in there, and in there also you can find a lot of complex usage of this Web3j unit. Yep. Okay, so this was about ERC-20, about the test interaction, and now what I'm looking to show you is the ERC-721, which is the smart contract specific for NFT, and I'm looking to create a Hyperledger NFT with you. Okay, so let me close this project. And also, we won't use the Besu this time as a network. We'll go directly on Sepolia and use the MetaMask wallet in order to be able to see it. But also, like, we could use MetaMask wallet also with Besu, but maybe a testnet will be more interesting for you guys. Okay, so now we'll generate, again, we have the same support for ERC-721. And we'll go with Web3j with the creation method. Let's create it with the same package. And also name. Workflow project, let's call it. Okay, let's find a token name for this ERC20. Let's call it hype token for Hyperledger. And as a symbol, let's use the hype. Okay, the creation is taking place. Open the project for you guys. It was here. And there it is, our ERC721 token project. Again, we'll try to do the same things that we did with the ERC20, except this time we'll do it on Sepolia network, test network, and also we'll interact with it as an NFT. Cool. So in order to get started, what we need to do is to change a bit what we have in here, and for that I will add the Sepolia URL. And
Can
also,
you tell them like if they want any RPC node, Sepolia RPC node, they can get it through Ethereum?
yeah, sure. Like, for example, in order to be able to get Sepolia testnet, you can go. Actually, we prefer Impura. It's really intuitive to use. And this is the link from where, and the endpoint from where I'm taking it. And also as a wallet, in order to be easy to interact, I'm using the MetaMask, and I have already some test Ethereum for this network that I generated before this call. This is initial what you wanted?
Yeah, cool. Thanks.
Okay, great. Cool. So as I was mentioning, I added the endpoint in here. Also, I will go again with the credential object, not using the wallet. Let me create that again. Oops. Also, the private key of the main account that I'm using to test. Dash. And let's see what we may get from it. So again, we'll run a deploy. Also, let me take the Web3j from here. Let's see that. Okay, cool. So now we'll run the deployment of our ERC721 smart contract. Okay, and we have the contract address that we'll add it again here. Okay, cool. And also let me extract this to a new method in order to have a clean space here. Nice. Good. So we have our smart contract ERC721 deployed in there, but what we are looking into is to obviously mine an NFT on and also see it somewhere. And for that, we'll create a new method and let's call it mined NFT. And for this, we'll load the contract as we did before for the ERC-20 and using here this contract address. Okay, so the smart contract is loaded, and now what we'd like to do is to start the mining. So, okay. And in order to be able to mine this, what we'll need to do is to call, like I will go on the Solidity smart contract. To give more context, we'll need to call this award item, because this would, what we really do is that will on this address, it will mine the new NFT, and that NFT it's in mem should be somewhere on the DB allocated by this URL. And for that, I'm using the NFT storage and also the NFT app tool, which is really easy to use because that is using IPFS. And I will show you just in a minute how to do that. I mean, mine, it's already uploaded, but I can show you the JSON documented how it looks like. But first, let's try to make a call. And also, as you've seen already, this one is returning an identifier. And the identifier mainly is the token, the NFT ID, which is unique every time. And by this, and this one is mainly the reason for the tool with which the double spending is avoided for the NFTs. Okay, so as I was mentioning, I will start calling that award item method. And let's mine it. I will use the same address of the contract, and I will show you later why, because again, we have to go through the same process of allowing the sending of from an address to another address. Okay, so in here we have the player, and the player should be based on this credential, and credential.get address. It will return the public address of this private key. Actually, it will be the public key, public address. Okay, and next I should send in here a new NFT URI, and for that, what adding here, create a new string. Actually, let's call it image URI or metadata URI, because then the NFT will be after it will be mined. And let's look what value to give it. Okay, so in here, as I was mentioning, I generated and uploaded my NFT already to the NFT storage. And just to show you, let's see if I have, yeah, in here. In here is the link that, this one is the link that will be used and added to the NFT URI variable and sent further for mining. And what this link should really return is a JSON with the metadata of the URI and of the URI of the image that will be used as the NFT. And for example, we have a name in here, which is Hyperledger. We have a description, which is Hyperledger or shop, and in here is the image, how the NFT would look like. And if we are taking further this link and paste it here, you see, this is how the NFT will look like. Mainly, it is the Hyperledger logo. Cool. So now getting back to our IntelliJ, I will add in here the link. Okay, so this is the metadata that will return that JSON. And this will take it further in my award item and send it. Also, this will return a transaction receipt. And in that transaction receipt, I will find the ID that was generated for this token. And in order to extract that ID, I will need to parse it a bit. And for that, I will use some type variables that are doing that mapping that I was mentioning in one of the slides from like EVM mapping, which is the one in here, mapping of the type unsigned integer of 256 to a big integer. And I'll show you now how to do that. Let's take it here. As I was mentioning, this one is returning a transaction receipt. And mainly we need to process this transaction receipt. And in order, this one is mainly contains a JSON, and for that I will find my NFT as my NFT index as a string, and for that I will use the following code. NFT index, or let's say ID. Let's see, but just a second. I think it should be in the logs. Let's not yet. And it should be the second log. And this is not really intuitive, I know, but this is, I mean, this is the way that we are supporting it right now. And we are looking to make this better. And mainly the data here is there is the return value of this function. So I will print it. But if I would like to use it in my Java app, I would like to use it more in like in a value that I know, and I expect it to be an ID, which it should be, I most probably will be a big integer. And also other thing is that this one, we will see here in the log that it will be 32 bytes padded, 0 padded. So I also wouldn't like that to be in there. So I will convert it right now to what type that I know. And for that, I will use the, let's say, big integer ID equals suite. I will use the type decoder and use the decode because I know what value it might be. It will be one numeric value, so numeric, and the input is NFT ID. And the type is uint 256 because I know that it will be this type from the method that returns it. Okay, and now what I'll go directly with value. And now I can write again. This and Washington here. Okay, cool. Yeah, so I think we have everything we need in here. Let's see what will be our success rate. Also, one thing just to show you, I will go back because I was mentioning that we'll use MetaMask. So this is my wallet. And here on the NFTs, we can see that right now I have this NFT on the Sequoia network, and also I have previously one Hyperledger. This one was just a dry run test before the workshop. But now what I would, and also you can see on it that it has the ID4 and also a different smart contract address. But now, after I run the code that I just wrote with you guys, hopefully I will get in here my new NFT. Okay, so let's run it, finger crossed. Let's see to what moment it reached. Okay, started mining the NFT. Okay, you can see in here that, okay, I forgot here to add the space, but that doesn't matter. The NFT was generated, and it was generated obviously as it was the first from the collection. It started from 0 as an index. And this is the value that I was mentioning that we'll receive it from this, from the transaction receipt. And by here I use this, they call the type decoder in order to get it to under a value that I would like to have it, which is big integer. And you can see in here that it was converted to 0. Okay, now what I should do is that I need to go to the MetaMask and to see if it shows in there. But as a hint, just to know if your NFT is not appearing right away, it is because it is a test network, and most of the time doesn't. It's not loading immediately. And the way you need to do in order to make sure that to load your NFT in your wallet is the following: just take the contract address of the NFT. Go back here on the NFT, and you have here the import, because you can do the refresh, but nothing will appear. And also one hint right before getting into this, go make sure that in security and privacy you have this auto detect NFT on. because most of the by default it isn't, and if it's not, then you have troubles in getting your NFTs, especially on the test networks. And okay, now what we are looking to is to import our NFT, and we'll paste here the address of the smart contract as I was saying, and also in here I will add the ID, and the ID was 0 because it's the first one which was created, and you see it you saw it already in the logs. And now if I click on import, okay, nice, my NFT was successfully added, and I can see in here the hype token that I just created, and also the smart contract address, the ID, which is 0, the description, and the image. Yeah, we have our Hyperledger NFT. Okay, cool. Next, this like I would like also to do a transferring here to see how it shows like from how it goes from one address to another. And also there are a lot of other functions that can be used in order to interact with this NFT. Okay, 1 second to check something in the logs. Actually, I'm looking for a hash. Let's see if it was printed by default. Hash. Not the block hash. Okay, in here, from what I can see, I have only these block hashes, but also in here I have a transaction hash, this mining. And I wanted to take it further to the Sequoia Explorer to see what it's like, what it shows. Okay, and in here I have the Sequoia Ether scan. And if I'm adding this here, okay, here we can see the details of the transactions. And we can see in here the method that which was called, which is award item. Okay. So we have to prove so far that this was a success. Great. Okay, getting back to our code, I will do one more transfer on this, and after we can continue with other things. And let me create the transfer method. NFT. Okay, so again, we're loading the contract. And what we need to do is to call the transfer function. And for that, we'll use because we will transfer it from the main address, we won't need to run any approval. So for that, we run transfer. Okay, so we'll use the main address credentials, get address. And let's add in here also the receiver. Okay, and as a receiver, use this address. Okay. Okay, and now we need to add in here the token ID, which is mainly the NFT ID that we just created, and we know that that was 0. and send at the end. Okay, also let's add some logs. And mention give set my NFT. And also add another log, and let's call my NFTs amount is I just remember that I have already one, so but first let me write the call balance and my address. Here I am expecting to have two NFTs, as I've shown you in the wallet, and after I will expect to remain only with one. And that one that was sent, I expected to receive it on this address. Okay, let's run this. Okay, so it seems we run into an issue. No worries about that. We'll check it right now. And in here we have a revert reason. Okay, let's see first the logs, if we receive these logs. Okay, okay, now I see. The query of balance of it's taking place on this specific instance that is using the smart contract address, and for that the result is one when I'm doing the query. So it's not two as mentioning before. The other NFT that I have is on another smart contract, and for that so that's why the balance in here is returning only one instead of two. And in here in sending my NFT, I think most probably should be the same reason that we had on the other side. Oh, okay, now I see. In here, I was sending the wrong ID. Because as I was mentioning, we have only one NFT on this smart contract, and that has the 0 as ID. Okay, good. It's good that actually that we run into this issue, because like this we can notice that how easy it is to mess up with the parameters. Good. So now if I run this again, it should work. Okay, cool. So it seems that the transfer took place. And just to check my NFT amounts in the logs, we have in here that, okay, before send we have 1 and after we have 0. And if I am going to MetaMask, it is here. So in here, just to do a short refresh. So we can see that I no longer have in here the collection, the Hyperledger collection. I have only previous owned items. And if I click on them, here is the an old item, which has the ID 4. And in here is the new item that was transferred with the ID 0. And if I'm going to the other account, also in here on my previous test, I had the same NFT with the ID 4, but now I should have in here the new NFT. And if it's not appearing again, we have to try to import it. And I will take now the smart contract address. And also the token ID, which is 0. And if I'm importing it, okay, nice. The NFT was added and it is with the ID 0. Okay, so yeah, this is the thing that I wanted to show you related to the ERC-721, how to create your NFT, publish it, and deploy it, and after mining it and transfer it from one address to another. Hope it makes sense. Ishal, are there any questions on this topic?
There's no any questions, but yeah, I will ask like participant, if you have any question, you can stop us anywhere. We can pause and explain more or dig deeper.
Okay, great. Hope this was intuitive. And yeah, in terms of tokens, this is what I wanted to show you during this workshop. And now we'll move on to the EAPs. And next, I would like to show you the EAP 155 and EAP 1559, how those can be executing using Web3j. And as we are already in, we have, now I see the time that we have already 2 hours in. For that, we don't have, I will jump on it, and I want to say that we don't have support to generate the project specific as it was in here for the ERC721 or the ERC20. But what I will do is that I will create in here a new class. Let's call it and add the code needed in order to be able to execute this kind of transaction. Okay, let's create a main function. Topic static. Okay. And for that, we'll use the credentials that are already used in here. So we have the node URL, we have the credential. Oh, I missed on E. No, sorry about that. And the main function. And one way to create the EAP 155 is to deal with the transaction manager class that is in our Web3j. And for that, I will just, as an example, I would create a raw transaction with using the transaction manager and specify in it the chain ID, because this is what mainly makes the difference from like a normal transaction to a EAP 155 transaction, and that is the chain ID, which is mentioned in order to make sure that, okay, this transaction is taking place on a specific network. And
I think
if you
there's a similar question only as you explained, like if you can explain briefly on what is EIP 15.
Okay. Yeah, now I was about to say that this EAP 155, what mainly does is that it's specifying the transaction, the chain ID. And that's because, like in the past, before this was created, there was a confusion, like in calling the main chain, the Ethereum mainnet, and the Ropsten, and most of the call were Ropsten mainnet, and most of the calls like were directing to the wrong networks, if I could say. And there was a mess in there. And for that, like, okay, the contributors decided, let's add this chain ID in order to make sure that the transaction gets on the right network. Okay, and yeah, just let me add in here the chain ID of the Sepolia, because we run again this transaction here. Should be long for this. The chain ID, the way that Web3j is using it, it has a long type. Okay, let me find the Sepolia chain ID. Had it somewhere. Okay, found it. Okay, so this is the chain ID specific to Sepolia, like, and also if we were to use Besu, so that one would have been 1337. A simple one. Okay, cool. So next, also, like I will execute a transaction using the transaction manager. And for that, let's create the instance of it. But also, like, let's see what we have in here. We have the node URL, the credentials, the Web3j service, and we need a guest provider. And for that, we'll use the default one. Nice, and now we'll put to trade the transaction manager. And also here the transaction manager is the interface, and we'll go for its implementation. And mentioning here the Web3j. And also, as I was mentioning, this is EAP 155, so we'll also need to specify here the chain ID. Nice. Cool. So what we'd like to do with this is that we'd like to send a transaction. And in order to do that, we'll need to call this send transaction. But this in here takes some multiple parameters. One is the gas price, the gas limit, where we would like to transfer it, what exactly would like to put on chain, and this is the transaction encoded value. Like it can be a transfer, it can be a control deployment, and also the value of the transaction. But this is for transferring from one address to another address. So for that, what I would like to do is to deploy a new smart contract. And for that, let me paste one in here. I have it. Let's create this new Solidity file and this storage. . Okay, so here I have a simple storage smart contract, which is like it acts as a getter and setter on a number. And for that, I will need to generate also the wrapper. And remember that I mentioned that in the beginning, in order to be able to generate the contract wrappers, then we need to specify it here. Okay, so storage Solidity smart contract is added to this list. Refresh it. Okay, where it is, okay, the Web3j, generate contract wrapper. Okay, so our wrapper is generated. And now if I'm going back here, I will be able to send the data that I need. For that, we'll use the gas, wider gas price. Gas limit also in here should be the null value because we are deploying it now. We are not sending to any contract. And as data, in here, we'll use the binary data as we are doing the deployment of this smart contract. And the binary of this, the compiled version of this smart contract is already included in the wrapper, and you can access it by this. I will call the storage. And you have here the binary. And then the value that we'd like to send is 0. Okay, and this is throwing an exception. Let me add in here the send transaction of transaction. And also I would like to get the transaction receipt of it, but it will take some time in order for the contract to deploy. And in order to make sure that I'm not getting a null pointer inception, here I will add a thread sleep of 10 seconds. Yep.
George, there is one question like why we are using broad transaction manager and what are transaction managers?
Well, we have multiple transaction managers depending by the case. And 1 second, I can go in depth to it. Like for example, you can have row transaction manager, fast row transaction manager. What is actually this does? This can handle multiple transactions, and by handling multiple transactions, I want to refer that it's able to send multiple transactions and to compute in advance the nodes for those transactions. And also other managers that we have, there are in a separate class is the private it's also the private transaction manager. But for this, as it is only a simple deployment, and I want to underline the EAP 155 with the chain ID, I'm using this row transaction manager in order to send my transaction. And for example, if we have here a read only, this doesn't, it's not updating anything. This can act only as a getter on the smart contracts. Hope this explains why I'm using the row transaction manager.
Yeah. And there's one more question, like can we do these transactions asynchronously, like send or sync?
Yes, we can do that asynchronously. We don't need to wait in here for a response. And also, like if you would like to, if you would like to use it in a Web3j in an asynchronous environment, I recommend you to use the transaction manager, because we can also create some transaction objects. We can also like run the transaction specific on the smart contract wrappers, but those are synchronous methods. And if you'd like to run it asynchronously, I recommend you to go with the transaction manager. Okay, and now I was mentioning about the receipt, and that is called, 1 second. Ethereum, yeah, transaction receipt. Sweet. The transaction update here and get the hash, because this is mainly the way that we're getting the transaction received. That JSON that we've seen before on the as a result of the wrapper execution methods. Okay, and obviously the send function in here. And also I would like to load my contract, based on this receipt, I would like to get my contract address. Let's see. If you go with debug, we'll understand how exactly this Ethereum get transaction receipt is built, and why I made here these calls in order to get all the way to the contract address. And also let's print it. Okay, and what else I would like to do? So I would like to load it in a specific object and to store a value and to get that value to make sure that, okay, my EAP 155 transactions, so transaction was successfully executed. And for that, I will go with storage, go with the contract instance. Plus provider. And I will use a storage of okay, and here I'm getting back the value that I'm storing. Let's check what we'll get. Okay, so in here I can see that, okay, based on this last log, I can see that my contract was successfully deployed using the raw transaction manager, and the value that was stored on it was successfully retrieved. So mainly this is like one way to execute the transaction with the EAP 155 transaction. Okay, and the last thing that I wanted to show you related to this, to the AIPs, and after initially step in with some more complex things. I wanted to show you the AIP 1559, but there is a bit to write on it. So I prepared already a class and we'll go through it and explain it. I hope this will make sense. This makes sense, and also like want to lose like 10 minutes in order to write it again. And for that, just let me create the new class, which is web 59. And I will add in there again code. Okay, great. So let's see, maybe it doesn't like something renamed.
I think the name is web app in there and the class is Web3.
Oh, okay. Let me see. Yeah, thanks. I'm getting a bit tired. Okay, let me rename this. 59. Okay, great. Thank you, Nisha. Also have you that we don't need. So, as some of you might know already, this 1559 is used to compute the gas in advance. And in order to like help the transaction to be mined ahead of other transactions, but by adding in there some certain values. And in here, let's just take it step by step. So in here again, where I'm creating the credentials with the private key. Also, I'm in here, I'm checking the client version, but this is only to check. And after what I'm doing, in here, I'm trying to compute the nonce for the transaction that I'm about to send. Because this time I won't use the transaction manager that will take care of that. I will use a transaction object. So in order to get the nonce, I'm calling this get a transaction count on the latest block. And this is the Web3j code that can help you to get that. Okay, and also next, what I'm looking at is to get the base fee. And this we tested some code before. Okay, so this is the base fee that I'm getting based on the block and printing out here. And after, what I'm looking to do is to compute this base fee. Like I'm multiplying with 1 by 1, 1.1 in order to make sure that my transaction will pass through. One second to check something here. Okay, it has a conflict with this. Base fee, let's rename it to final. Okay, and after like I'm computing the base fee for the transaction, I'm creating the EAP 1559 row transaction. And in here, you can see that I'm using this row transaction object, and I'm calling this method on it. And if we are taking a look closer to it, in here we can see that there is the arguments that is taking are the following: is the chain ID, the nonce, the gas limit, the where to send this transaction, the value, the max priority fee, how we how we would like to use this EAP1559 in order to get our transaction through, like paying some more gas to the miners. And also in here it is the max fee per gas that should be mentioned in order, okay, I am allowing this much for my transaction in order to get through. Okay, and now if I'm getting back here, and this is a smart contract where I'm sending and this is an address where I'm sending the value, because in here, I don't know if you notice based on the composition, but this one it's transfer. Like it is the chain ID, the nonce. And here is the gas. If we are going back here, the gas limit, where I would like to send, the value that I would like to send, and those two fields specific to EAP 1559. Okay, and also like I need to give some credits to Initial for creating this method in here. Okay, and now if I run it, and in here again, it's waiting in order to be able for to process the initial transaction that was sent here and to get the receipt. And this should have been removed from here because it won't work. As you can see, it's already removed. Okay, but in the meantime, we can check what logs have been printed. And if, for example, if we're going to the base fee, we can see that the base fee for the node that we queried, which was the latest, I mean, for the node, for the block that was queried, which was the latest one, was this amount. And obviously, like when we went further, we multiplied this with 1.1 in order to make sure that, okay, we'll allow this much gas in order for the transaction to go through. And that was specified in here in the create transaction. And also other thing is that we added a tip for miner, and the value of the tip was this much, which is 5578. But if we're going all the way down, we can see that the transaction was executed. We received the hash for the transaction. And also we can find in here the block number, the cumulative, the gas used, and the transfer that was taking place from this address to the other address. And also as it was executed on Sepolia, I'll go now and check it here in the scanner. So it was 123 way transfer from this address to the other address with this value. And if we're going to check the details, we can see the priority gas fee that we put in there and the other parameters. And also just to go back here to show you, here is the priority gas we added and also the value that we transferred. Value transfer and the priority we added, and also the base fee that we placed earlier on by multiplying that gas that we received. I mean, the gas that we queried here, because multiplying this by 1 to 1, it will return value of this. Yeah, and this is mainly how you can execute the EAP1559 transaction using Web3j, and also another way to execute the Web3j transactions by using the raw transaction class. And in here you can find some other type of transactions that you can execute. Okay, this is what I prepared for the workshop today. Hope it was useful, that you like it, you enjoy it, and from now I hand it over to you initially if there aren't any questions.
Thank you, George. I think we had a few questions, but we were able to resolve with chat, and you can also go through it.
Okay, sure. From now on, I will stop sharing and also try to help with the chat.
Yeah, sure.
Okay, so I'll stop sharing screen, and would you like Nishor to step in to show the 4844 new VIP?
Yeah, sure.
Okay, great.
Oh, thank you so much, George, for all the for the presentation demo. Okay, so I think as you all will be knowing that 4844 were recently upgraded with Cancan upgrade in Ethereum on 13th of March, and there's a lot of hype how it can decrease the cost of transactions in layer twos. So basically, there will be a temporary storage of um, of temporary storage in the form of blob, which the layer 2 transaction can send over the layer 1 network. So when we started with this development of EIP 4844 so that all the users can get benefit of this EIP, and they can transact the blob transactions over the network. So I already have, is this visible or do I need to make it a little big?
You can make it a bit, you can zoom in because, I mean, the screen is really wide and it's hard to read.
Just make this. Just give me a second. Yeah, is it fine now?
Yeah, way better.
It's much better. Thank you.
Okay. Thank you. Okay, so what happens in blob transaction that we can send a blob to basically 1 to 6 blobs in a transaction, and this goes to the consensus layer and then to the execution layer. So in execution layer, it is not stored. It stays in the consensus layer for about like 30 days, where we can like check, okay, so this is the where we can retrieve the basically blobs. So to make a blob transaction using Web3j, so I already have some code here. So here we are using going to use the Sepolia network testnet only, and we have the private key. Basically, this is my private key I'm using. Uh, and then also, don't worry, there's just a testnet, so you won't be able to steal my cryptos. Okay. And then I'll just create a credential, and then we have the address, and this is the HTTP service using the node URL, the RPC endpoint we got from the Infura. And then what we are going to check the balance of an account. And once we have the balance of our account, as the George said, we can get the transaction count. This is basically the nonce for our account, which we are going to provide. So we are going to print the nonce. Then to make a blob transaction, we need to give the blob base fee. And we have already the formula in the spec sheet of AIP 4844, how to calculate a blob base fee based on the excess blob gas and the current blob gas used. So based on those two values, we can basically get the blob base fee. So it is already implemented in Web3j. We can directly get those value using this Web3j dot ETH get base fee per blob gas. So once we have that, so in ETH block, there are two more parameters which were introduced in EIP 4844. So as I said, one was ETH blob gas used, and then the excess blob gas. So we can get those two values here, and we can show what's the current blob gas used. Okay, and after that, we need to, make a transaction. We need to give a value of blob fee, basically somewhat bigger than the current blob fee. So even if it increases, our transaction doesn't fail. So that's what I'm just multiplying it with 1 by 1.1 value. So we have the enough blob fee. And to create a raw transaction, what I'm going to do is, so we are going to create a list of blobs. So we can add up to 6 blobs in here. So let's add. So currently here we have only one blob. Let's add 3 blobs. Okay, so basically what this function is doing, it is randomly creating a blob using this code. So this is just randomly creates a blob of the expected size, and then we are going to get this random blob added to a list, and then create a transaction. So in here we have the list of blobs, then the chain ID, the nonce, what we get from the transaction count. So from here, that's the same nonce we are inputting. And then this is the base fee gas, basically gas limit, and the gas price, those things, max, those things. And then this is the two address where we want to send this blob. And then if we want to send any ether along with it, so we are not going to send any ether, so value is 0, and no data we are going to send in here. And lastly, the blob fee. So this is the blob fee which we calculated in here. So using this, we are going to create a raw transaction, and then we are going to sign this transaction with our credentials, and then send it to the network. So we are going to send it to the Sepolia network. And once we send the network, we are going to get the hash, and we can check the response, what was the response, and get the transaction receipt. And if there was any error, we can get those things also. So I will just quickly run this. So this is the account address I'm using, account address. Then the Web3j client. So basically this Infura RPC node is using this client, get 1.13.14. And then if you see, this is my balance in the account, and the nonce is currently 7. So this is the 7th transaction from my account. And the current blob base fee is this much. And the current, the last blob gas used in the network was this much, and then the excess blob gas was this much. So these are two values which we can retrieve from the ETH block. So after that, you can see the transaction hash. So we have already sent the transaction, and we get the transaction hash for that. So currently transaction response is null. So it is not like returning anything. So its response is null. So after we get the transaction hash, we are just waiting for it to get mined. So I have implemented a sleep of like 60 seconds. So once that is complete, we'll poll the receipt. So we'll get this transaction hash and send it. So if you see, we got the transaction receipt. So let's see here. So in this, you can see the transaction index, then the block hash. So in which block it was mined, and this is the my address from address. And if you see here, we will have effective, yeah. So what was the blob gas price? So this is the blob gas price, and the blob gas used was this much. So we can get all these things and send a blob transaction. So I'm just go to my Chrome and show you this transaction. So let me just copy this transaction hash. Okay. So first I will check the Sepolia ether scan. Okay, so second, just input my transaction hash. So if you see, there are 10 block confirmations. So transaction was successful, and this was the transaction fee. This was the gas price, and all the base fee, and then the gas limit. And there were three blobs. Or if you see, I added three blobs. Yeah, so I added, or if you check, we added three blobs. So these are the three blobs which we have. So if I click on here, so these are the blob version hashes, and this is the commitment. So these are the KZZ commitment hash and the version hash basically. And the blob size was this much, and the blob base fee, blob gas price, blob gas used, all the things we can check it out here. Also, there's one more website which is blob scan, where we can check the blobs. So I just go to that, input my transaction hash. So if you see, it was 3 minutes ago. This in this block it was mined, and if you see, these were the blobs, three blobs. And if I try to open this, so this is the total blob which was sent. So if you see, we have all the blob which was stored, and also we can see the version hash, the commitment, and the proof here. So using this, basically, it will be very easy for all the developers to test the new EIP 4844, and you can send these transactions to layer 2 network, and you can basically create your own Web3j app, and you can basically and I think this is the first library, Web3 library, which implemented this EIP 4844 support. So yeah, please go on and create blob transactions and try this, and let us know if you face any bug or anything. We'll try to fix that. Is there any questions in the chat?
Yes, like we got one question. What exactly do you mean by three blocks? I think you wanted to say three blobs that were added. Well, what exactly do you want to mean by this?
Okay, so in EIP 4844, basically you can add blobs. So blob can be any data. So basically what happens when a layer 2, when you do a transaction on layer 2, the proof of these transactions are then sent in compressed form to a layer 1 network. And it used to be done in the call data value, but it was very expensive. So with EIP 4844, what layer 2 can do, they can create a blob. This blob is just a data from the layer 2 network, which is a proof of the transactions in layer 2. And they are sending this proof and storing it on the layer 1. So it is secured by the layer 1 network also. So a blob, when we say we are adding three blobs, so basically there are three storage blobs which contains the data of the layer 2 network, which we are basically storing it and securing it on the layer 1. And currently the Ethereum network supports blobs up to 6. So, and maybe in future they will increase it if we want to or decrease the uh, basically the prices more, and we can store more on the layer 1 networks. I hope this explains.
Yeah, I think that makes sense, but we have another question, and that is if you can give other example than and not including layer 2 about this blobs usage.
So basically, okay, so
like
what we
it's
can
a
say,
proof, like for example, also the user added if this is a proof of transactions.
yeah, so basically what is happening, the storing on layer 1 on Ethereum network is very costly, right? Because it's a permanent storage, and every peer in that network needs to, store the same value. But right now with the blobs, what is happening? It is a temporary storage. So every network just need to store this blob for some days and do not need to, store it permanently on the network. So basically, you can use it as a storage for basically as a temporary storage on layer one. So there was some use cases where people were, converting a image or NFT into a blob and storing it on the layer one. So there can be many use cases. So basically, um, it basically makes it easy for users and make it like less costly for users to store the data on layer one. We can say blob basically makes it easy and less costly for a user to store data on layer one because it's a temporary storage.
Yep, I
I
think
hope it
that
makes
address
sense.
that really well. Yeah, it makes sense.
So,
We got the answer from the user.
okay, I'll just stop sharing and yeah. And also, there's
Could
one more
you?
question. Yeah. So just last thing, there were some questions from user when we are doing Web3j introduction, how we can, how we can get the event filters and we can get the events parallelly. So I have created one project for that too. So basically, what it does, this is a Hello World contract. Let me show that. So what it does, it stores a greeting message, and when we change this greeting message, it creates an event. Um, yeah, so it basically emits a modified event, which we can check and we can basically log this event in our Web3j app. So this is what we are going to show in our Web3 app. So basically, it will deploy the smart contract and then it will try to change the greeting address from to different basically to different greetings. And here we are running a parallel execution thread where we will going to a log the old greeting and the new greeting. So using this you can basically get these events and you can make sure like what were the changes done on the smart contract, and if there was any function which basically emits a event, you can get that. So I will just run this. So for this I need to start my network. I think George has already explained this, and if you have any questions on the chat regarding filters. So if you see, we have created a filter and it is from the earliest block to the latest block, and this is the contract address we are giving for the deployed contract. And if you see all the events where there's a modified greeting, we are going to give this filter as a parameter, and we are going to get the events for that, and we are going to subscribe to that event and log those events. So I think my network should be up. I'll just check once. Yep, it is up, healthy. I will also check the Docker if it is running fine. So this is the Besu QBFT network, and we can check the logs if the network has started. It's still starting up. Just Wait few more seconds for it to start.
Nishal, could you please zoom in again a bit because it's hard to read it to see your screen like this on a smaller screen.
Okay,
Yeah.
okay. So I'll just make it a bit bigger. So if you see, the blockchain has started mining the nodes. Is it visible now?
Yeah, it's visible, but it's really small. This is what I was referring to. But I don't think we can do as we are in this Docker interface. I don't think we can zoom in.
Yeah. So basically, what I want to show is we have started the blockchain network and it has started mining. So now we can make the calls. So just run this. Once it is deployed, we should see the contract address. Not yet deployed. Okay. It's deployed. We got the contract address. After we got the contract address, we are going to create a filter and we're going to subscribe to all the events. So let's check the greeting method result first. This should be hello world example. Yeah, it's hello blockchain world. After this, we are going to change it to Nischal and then George. So let's see if we get those events. I'm going to search this. Okay, so if you see, the old greeting was hello blockchain, then there was an event emitted and it changed to Nischal. Then we can search again. Okay, so again there was a event where the Nischal was changed to George. So we can continuously get poll these events and we can make sure what are the changes in the contract, basically smart contract using these events. So I hope it makes sense and let me know if there's any question yet.
Well, we got a question related if the latest block is finalized, but I didn't really get that. So if
Or maybe he
Mariano,
wants,
yeah, please, Nisha.
so maybe so he wants to know the if the uh, basically the block is finalized. So basically what happens in private network where we're using QBFT or IBFT network, all the blocks that is mined is a final. So in public, there are chances the block mined now is not final. So we rely on block confirmations. But in a private network, which we started here, these all blocks are final. Yeah, George, please. I hope.
Yeah, it answered that.
I'll just terminate this and yeah, I'll just stop sharing them. Okay, latest attribute is basically the last block that is mined. Yeah, over to you.
Okay, thank you, Nisha. Thank you so much for all the great stuff you did with the EP 4844 and also with the log events. And yep, we seems that we got to the end of this workshop, and it took us nearly 3 hours. I mean, exactly 3 hours. So we made it. And in here we have I think this is the last slide with the summary that we did. So if you remember in the beginning, we talked about the Web3j architecture, the modules. Also, we went through the ERC-20 and ERC-721 contract wrappers and also how to generate projects based on that and how to deploy them on the EVM networks. We interacted with the local Besu network. We interacted also with the Sepolia network, where we deploy smart contract, also like transfer tokens, transfer NFTs. We've seen how to create an NFT, what exactly it's sorry, metadata, how to specify it, what methods to call. We also took a look in the Web3j unit, and we've seen how that can be extended and used based on our case, how to create proper integration tests using in behind the node that we want, the embedded EVM node, a Docker, Compose one, or Besu or Get node. And in the end, we finish with executing the EAPs, the most used EAPs in this EVM space, which are the 155, 1559, and 4844, which we assume will bring a revolution to the networks having the possibility to bring these chunks of data. And yeah, thank you so much for staying with us for so long, and hope everything was clear and makes sense. And yeah, we are looking for your contributions as well. And now I'll move again to this because it's very important. Like if you'd like to join and to subscribe to our Hyperledger community, it will be really helpful. You will find the latest news related to Web3j. And also we are inviting all of you in our Hyperledger Web3j community calls, as Nishal was mentioning. We'll have the first one next week. So yeah, looking for you to be there and to debate more on Web3j and help us developing. Sorry, yeah, I need to grab some water.
No worries. I would like to, on behalf of Hyperledger, thank George and Nishal for doing such a great job. Please, nobody leave yet. I got a couple things to say. We'd like to thank George and Nishal for doing such a fantastic job on this workshop. It was really informative, and the questions were fantastic. So thank you to both of you. I would like to thank everyone who attended, even those who had to leave early, who are going to check back in on YouTube. Open source works because of you. Using the software, contributing to the software, becoming maintainers, sharing this workshop with folks is how open source grows and works. And I cannot thank all of you enough for joining us and asking such fantastic questions. As I mentioned a couple of times in chat, the links, the deck, and this video will be shared in a thank you email to all the registered users. Those links and deck will be shared in the YouTube description in case you want to come back and check it out, and as well as on the Hyperledger wiki. We live stream this, so it'll be on YouTube like in the next, it's on YouTube right now, but the final encode will happen like probably in the next half hour. And please, by all means, check out the Web3j community calls, check out the Discord, check out the GitHub pages for Web3j. We cannot thank you enough for joining us today. And please share this with your colleagues or friends who are interested in this topic. But again, thank you, George. Thank you, Nishal. Please tell Connor we said thank you as well. I know he had to leave a little bit early. And thank you, everybody. We're going to I posted the links again in chat, and it'll all be in YouTube and on the wiki today. So thanks, everyone.
Thank you. See you.
Thank you.
Bye.
Thank you, everyone.